that. That's like an entire new process. There's really nothing more to add as far as a single mutation that would cause us great things. Now, sickle cell, cystic fibrosis, or any other genetic condition, including those that are cancer related, those are mutations. But when was the last time you heard of like having a carcinogen like cigarette smoke or UV rays and that being a benefit to your health? Never. So the things that cause mutations we always associate as being negative. So we associate mutations as negative. Was that Joseph? Okay. You want to talk about it, buddy? Oh, he seems so sad. Okay. No one's going to watch this video anyway. Population. I want to make sure we can understand what this term means. What is a population? Right. Localized group of individuals of the same species. And let's talk about the gene pool. The gene pool is referring to all alleles for a specific locus in a population. Have you ever heard of like there being a shallow gene pool? You ever heard that expression before? Gene pool's wow, really? Oh God. Okay. Okay. Well, let me ask you this question. This is a true story, or no, I don't want to tell you that story because that's too negative. What if you were living in a town of like 400 people? Okay, and the town was sealed off. Like there was a dome, like around the city, around the township, and no one could leave, no one could enter. You know, like let's just say there was randomly 400 people from this planet. No, let's just say the DFW area. Randomly 400 different people from this DFW area. They're put in the dome. Well, initially there's not going to be any kind of inbreeding. Agreed? Like initially, like you're gonna like the mate would be someone completely different. But imagine like after like 6 or 7 generations, you know that like some random cousin situation is going to be happening. Agreed? I mean, like that's just the way it would be when you have a town that's like sealed off completely. It would be inevitable that would happen. Okay. Well, that would for sure be a human population, and that would be their gene pool would be all the mixes of the genes they have. Let's say that they were people from DFW, and let's say that they were people that were every nationality but that of any Asian nation. So, would you have any people like of Asian descent? No, not at all. Which means any of those genes would be completely absent. Does that make sense? So the gene pool would be absent of those unique traits. What if you took people that you knew were big T for the cystic fibrosis allele? There was no little t's. Well, that means that there would be nobody with a little t for cystic fibrosis. Does that make sense? Okay, so I want to talk about gene pools and populations, and I want to talk a little bit about some math. We've all taken Algebra 2, correct? Okay. Okay. So I'm going to give you a question from math, and I need you to solve this for me. You can solve it in your head or you can solve it on paper. I guess I don't really care. It's really not solved. This should just be simplify. I'll give you like maybe 10 seconds to solve this. Okay. Okay. Like that? What do we call that? Foil? Is that so what they call it these days? Okay, that's good. That's what I called it when I was a child. In the 2nd grade, I think is when I learned this. So, yeah, foil. Good? Okay. let's go back to genetics real quick. What was the guy that was all about genetics? What was the guy that did the pea plants? Okay, so let's talk about Mendel and the Punnett square. Are we still doing okay? You'll see why we went over that in just a second, I think. Good? Hopefully everyone's paying attention, because I can promise you I've taught this every year, and the people that I can tell are not in the zone, you'll be like, I don't get it. In 2 minutes, you'll be like, I don't get it. And I will be like, YouTube it. Ready? Okay. Let's do something like this. Let's take two heterozygotes. You know what heterozygotes are, right? Big T, little t's. And I'll let you go and fill in the blanks on the Punnett square. Did you get what I got? Okay. Is the big T and the little t, are they the exact same genetic sequence? Please, not all at once. They can't be. They're coding for two different things, right? Big T is coding for tallness and little t is coding for shortness. So they cannot be identical. So since they're different, I think instead of just saying big T, little t, I want to call one by one variable and one by a completely different variable. Not a capital lowercase, but two completely different variables. So I'm going to redo my Punnett square for two heterozygotes, but again, instead of using t's, capital and lowercase, I'm going to use two totally different variables. And on purpose, I'm going to choose the variables p and q. P and q. Now let's remind ourselves, based on how you saw the previous Punnett square, what would the p variable be referring to? The heterozygote allele, or I'm sorry, the dominant or the recessive allele for p? So p is for the dominant allele, and q is for the recessive allele. Okay? So I'll let you do this cross real quick. Just like that? Did we get it right? Yes, Mr. Fields, I was able to multiply. Okay, very good. Now, let me go back to maybe this question. Let's say that this was big T for tall and little t for shortness, so that was tall, 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 and then short. Okay, I like that. Now,
sorry, I'm late.
welcome.
Thank you.
Okay, so let's say that this was for tall and this was short. Let's say that you could only be big T, big T, big T, little t, little t, little t. What if I took the percentages of these and I added them all up? What should their total percentage be, adding them all up? 100, because if you can be either tall or short, if you can be one of these setups, then the sum of all of those would be 100%. Agreed? Are we still okay? Do I still have everyone in the zone? Okay, I want to make sure. So we were just left with a situation like